Welcome students. So today we have lots of the PYQs question which is a came in the board examination, and for the board examination that is a very important question also. So let's begin with this objective type question and the practice set 2. The first question we have: if 10 million electrons are removed from neutral body, then the charge on the body is. We have an options. Now I'm giving the few seconds to you to solve that particular problem. Hope you did. Let us see the solution of this question. So Q is a given as a positive integer. So that is a 10 million electron. That means 10 to the power 6 into 10, 1.6 10 to the power minus 19. So we have a 1.6 10 to the power minus 12 coulomb. That means the correct option is 2. Moving ahead with the next question. 1 million electrons are added to a glass rod. The total charge on the rod is. Try to solve this problem. So the correct answer for this question is, for the solution part is, Q is a negative. So Q is equals to minus 1.6 10 to the power minus 19 into 10 to the power 6, because this will be 1 million only. Q is comes minus 1.6 10 to the power minus 13 coulomb. According to that, the second option is our correct answer. Moving ahead with the third question, 10 to the power 20 electrons are removed from a conductor. The nature and magnitude of the charge developed on it is. We have an options. Try to solve this problem. So the solution of this question is, Q is in positive because the electrons are removed. That's why we have taken this one is a positive. Q is equals to 10 to the power 20 into 1.6 10 to the power minus 19 coulomb. So the answer Q is equals to plus 16 coulomb. According to that, the first option is the right answer. Next we have two equally charged with balls 3 centimeter apart repel each other with a force of a Newton. The charge on each ball is. We have an options. Try to solve this problem. Now see the solution of this question. So the formula which we have, F is equals to 1 by 4 pi epsilon naught Q square by R square. I'm just putting the value of R, which is given 3 centimeter. If I convert this centimeter into the meter, we get 3 10 to the power minus 2 meter. Now after putting all these values, we can calculate the value of a Q. So the value of a Q is equals to 2 10 to the power minus 9. According to that, the correct answer for this question is option 2. Moving ahead with the next question. The ratio of the electrical force of attraction to the gravitational force, the proton and electron of the hydrogen atom is of the order of. We have an options. Let us see that how many times you have taken to solve this particular problem. So let us see the solution of this question. F is equals to Fe by Fg. If we just put the value of Fe, that is a Q1 by R square. So we can write up as a Ke square by R. And the value of a G, Fg is equals to Emp divided by R square. So both the R square will be cancel out each other and we get the result Ke square divided by Gmemp. Now here K is equals to 1 by 4 pi epsilon naught, and the value of 1 by 4 pi epsilon naught is 9 10 to the power 9. MA is given here 9.1 10 to the power minus 31 kg, and MP we know that 1.67 10 to the power minus 27 kg. We just put all these value and get the option first. Hope you also get the same. Next we have a charge Q is placed at the center of the line joining two equal charges Q. The system of three charges will be in equilibrium if Q is equals to. We have an options. So try to solve this particular question. Hope you did. Let us see the solution of this question. Q naught is equals to minus Q 1 by 1 plus Q2 by Q1 whole square. So this will be applicable formula when we are just taking three charges in the system. So after putting all these values, we will get the value of a Q naught, which is a minus Q by 4. Hope you also get the same. Next question we have a charge of a 10 unit is divided so that force between the two charges is maximum when placed 2 centimeter apart. The two charges are, we have an options. Try to solve this particular problem. Hope you did. Let us see the solution of this question. So F is equals to 1 by 4 pi epsilon naught Q. Q minus Q divided by R square. We just put if the force is a maximum. The situation is that dF by dQ is equals to 0. In this situation, we just have to differentiate this formula and we get the result. And the result is Q minus 2Q is equals to 0. After solving, we get Q is equals to Q by 2. Here Q1 is equals to Q by 2 and Q2 is equals to Q minus Q by 2. That means Q1 ratio Q2 is equals to 1 ratio 1. That means the correct option is 4. Next we have two identical metal sphere possessed plus 60 coulomb and minus 20 coulomb of charges. They are brought in a contact and then separated by a 10 centimeter. The force between them is. These are the options. Try to solve this particular problem. Hope you did. So let us see the solution of this question. After contact, the force will be 1 by 4 pi epsilon naught Q1 plus Q2 whole square divided by 4 dQ. When I'll just put all these values, I'll just get the value of a force, which is 36 10 to the power 30 Newton. According to that, we have a first option is the correct option. Next, we have two charges, each of 100 microcoulomb are separated in a medium of relative permittivity 2 by a distance of 5 centimeter. The force between them is, we have an options are these. Solve this problem and then I'll just get the solution and then match it. I hope you did. So the solution of this question, F is equals to 1 by K 1 by 4 pi epsilon naught Q square by R square. Put the value of all these terms and we get the result, which is of 1.8 10 to the power 4 Newton. According to that, Fourth option is the right answer. Hope you also get the same. We have a next question. The force between two charges, 2 microcoulomb and is 4 microcoulomb is 24. When they are separated by a certain distance in the free space, the force, if A, distance between them is a double and the B, distance is a half r. We have an options are these. Try to solve this problem. Hope you did. Let us see the solution of this question. So we have a F is proportional to 1 by r square. Now, if we change the value of a distance, so the force will be changed. That is, F prime is given as a F by 4. So that duration, the value of a force increases, which is 6 Newton. Now, if the force will be 4 times, then the value of a force will be 96. According to that, we have a correct option is option 3. Next, we have 3 charges, 1 microcoulomb, 2 microcoulomb, 3 microcoulomb are kept in at the vertices A, B and C of an equilateral triangle ABC of 10 centimeter side, respectively. The resultant force on the charge at C is, we have an options are these. So, solve this particular problem. I hope you did. Let us see the solution of this question. Fr is equals to root 3 F root 3 1 by 4 by epsilon naught q1 q2 by L square. So we have this particular diagram. According to that, we can get the result of a F prime, which is a 2F cos theta by 2. Here theta is equals to 60. We just all this value put in this particular formula and get the result. According to that, the fourth option is our correct option. Moving ahead with the next question, two positive charges Q1 is equals to 4 10 to the power minus 6 coulomb and Q2 is equals to 9 10 to the power minus 6 coulomb are placed 10 centimeter apart in air. The position of the third charge to be placed between them such that there will be no resultant force on it is. The options we have 6 centimeter from Q1, 3 centimeter from Q1, 4 centimeter from Q1 and 7 centimeter from Q1. So try to solve that particular problem. I hope you did. So let us see the solution of this question. Null point x is equals to d by under root q1 q2 plus 1. I just put all these value, okay, in this particular formula. So we have an charge by which the distance x and 10 minus x are located here. So E1 will be the E2. So Q1 by x square is equals to Q2 by 10 minus x square. We just put all these formula and then get the value of x, which is the 4 centimeter. And the correct option will be the 3. Moving ahead with the next question, 3 charges minus q plus q and minus q are placed at the corner of an equilateral triangle of side A. The resultant electric force on a charge q placed at the centroid O of the triangle is. We have an options are these. Try to solve this problem. Now let us see the solution of this question. So we have this particular diagram where Fr is equals to 2F. We just put this particular data in this formula and get the option 4. Next question, we have a charge of 2 microcoulomb is placed at x is equals to 0 and a charge of minus 32 microcoulomb at x is equals to 60 centimeter. A third charge minus q be placed on the x-axis such that it experiences no force. The distance of the point from plus 2 microcoulomb is, we have an options. Try to solve these options. Hope you did. We have in solutions x is equals to d, q2 by q1 minus 1. Put all these values in this given equation and get the value of x, which is 20 centimeter, option number 2. Another question, we have a force F is acting between two charges in air. If the space between them is completely filled with the medium having dielectric constant K is equals to 4, the force will be, we have an options F, 4F, F by 4, 2F. Try to solve this question. Hope you did. Now the solutions we have. F prime is equals to F by K if the medium is involved. So the correct option is F by 4. Next question, we have an electron and a proton are sent into an electric field. The ratio of a force experienced by them. We have an options. Try to solve this question. Now move ahead with the solution. So F is equals to QA and Q and E are same here. F is same, that means the ratio is 1:1. Moving ahead with the next question, an electron of a mass is given is sent into an electric field intensity 9.1 10 to the power 6 Newton per Coulomb. The acceleration produced is, we have an options are these. Try to solve this problem. So we have a solution. I hope you did. A is equals to E by M. We just put this value in the equations and get the value of A. Move ahead with the next question. The force experienced by chloride ion having 4 electrons removed when placed in an electric field of intensity 2 Newton per Coulomb is. Options are these. Try to solve this particular problem. Hope you did. Let us see the solution of this question. So F is equals to QE and Q is equals to 4 times E. We just put all these formula and get the result, which is option 1. Move ahead with the next question. An infinite number of electric charges equals to the 5 nanocoulomb are placed along x-axis. X is equals to 1 centimeter, X is equals to 2 centimeter, 4 centimeter, 8 centimeter, and so on. In this setup, if the consecutive charges have opposite sign, then electric field is in Newton per Coulomb at x is equals to 0 R. So we have these options. Try to solve this particular question. Hope you did. So we have solutions. E is equals to Q by 4 pi epsilon naught, 1 by 1 square minus 1 by 2 square plus 1 by 4 square plus 1 by 8 square and so on into 10 to the power 4. We just put all these value because this value is get in this GP form and we get the result, which is option 3. Moving ahead with the question number 20, a proton of a mass m charge E is released from rest in a uniform electric field of strength capital E. The time taken by it to travel a distance small d in this field. We have an options are these. Try to solve this particular problem. I hope you did the solution. Let us move ahead with the solution part. So we have a t is equals to under root 2t divided by E by m. We just put all these values and we get the result. Next question we have four identical charges, each of 1 microcoulomb, are placed at the corner of a square of a side 10 centimeter. The resultant field strength at the centers is. The options are these. Try to solve this problem. Hope you did the solution. Let us match your answer. So force cancel out each other. That means the resultant force will be, the resultant strength will be 0. Next question we have a charge Q1 exert a force of 45 Newton on a test charge Q2 is equals to 10 to the power minus 5 coulomb located at a point 0.2 meter from Q1. The magnitude of Q1 is, we have an options are these. Try to solve this problem. Hope you did the solution. Let us see the solution of this question. You can match your answer. So we have this formula. We just put all these values in this particular formula and get the result, which is 210 to the power minus 5 coulomb. According to that, the second option is the correct option. Next question we have two charges of a 10 microcoulomb and minus 90 microcoulomb are separated by a distance 24 centimeter. Electrostatic field strength from the smaller charge is 0 at a distance of. We have these options. Now try to solve this particular problem. Hope you did the answer. Let us see the solution of this question. So we just put this all the data in this particular formula and we get the result of x, which is 12 centimeter. Hope you also did the same. Moving ahead with the next question, 24. A charged particle of a mass 5 10 to the power minus 6 kg is held stationary in a space by placing it in an electric field of a strength 10 to the power 6 Newton per coulomb, directed vertically downwards. The charge on the particle is. We have these options. Try to solve this particular question. Hope you did the solution. Let us match your answer. So mg is equals to qa. We just put in this particular thing in this formula and get the result, which is option 3. So student, this is all for today's class. Till that, for the next class, wait for the next class, and till that, take care everyone.